Good morning, everyone, and welcome to our webinar. My name is Fawzi Bawab, and it is a pleasure to be here with you. We are on time, 11:30 UAE time. I'm broadcasting from Dubai, and it is a pleasure to have you all on this exciting webinar. I believe in punctuality, so let's get started. Basically, we have a very interesting topic ahead of us, which I will try to cover within our time frame. I know it's a very fascinating topic that is very helpful to quality professional, improvement professionals, but we'll try to shed some light on the important concepts and then move to the last session of the Q&A. So if I may ask you, maybe just to leave your questions till the end, you can send them via the chat function, or if you want to have a verbal chat, we can have it at the end. So welcome again, and let's get started with the fascinating topic of statistical applications to processes and to performance capability. Now, just a quick note, we are recording this webinar, so you can have access to it through our website, Merck website or YouTube channel. So you can later on come in and maybe view the slides and the discussion and maybe expand your knowledge at any time that you want. Now, the program, I've devised the program and the agenda to be able to cover some of the important topic when it comes to statistic and process capability. First of all, we need to answer the question, why are we discussing this topic? What prompts me to actually discuss this topic? I know it's sometimes statistics can be overwhelming, but it is indeed a very important tool for us and quality professionals or improvement professionals in general. So we'll talk about that. Then we will refer to the 7 fundamental quality control tools. We are basically focusing on 2 of these tools, which is the control charts, and then we are focusing on the histogram and using it as a process capability tool. If we have time, I have included a little bit of applications on the famous software Minitab, so we can practice a little bit maybe on using the control charts or generating control charts using Minitab and then the process capability charts. So then we will venture into the SPC or statistical process control, purpose and benefits, and how can we use it in our everyday life? You know, whether you are a healthcare professional, whether you are in retail, whether you are in trading, whether you are in government services, transactions, manufacturing, how can we use it in our daily life to monitor and to have some kind of an examination of the process variation over time? Once we do that, we will move to the application. So we'll do a little bit of control chart applications. I know we can spend the whole day on control charts, but I've selected a number of slides that can give us a little bit of more information on the control chart applications, and hopefully we can use Minitab to generate that. Then we will move to another topic, which is called process capability. What is process capability and how can we use it to measure whether we have a good process? Now, define good, we will talk about that and see how we can use it in every type of a process to understand the process capability in meeting customer demands and customer requirements. So we will practice and maybe take an example file where we can generate maybe a process capability chart and then read it. Takeaways and then Q&A. So please keep your questions and then you can send them through the chat function, or if you want to chat verbally, I'll be more than glad to do that. I guess everything is fine unless you have any remark using the audio quality and the video quality should be fine. Just a quick remark or a cap on the company I represent. It's called Merck Training and Consulting. We are one of the leading training and consulting companies in the region. You can see that we started in 1958, so we've been here for a while. We work in the Middle East region as a general playground for us. We offer two types of services. We offer training services and we offer consulting services. We have over 300 courses. So, courses that can cover from project management to quality to strategy to customer service. And, once you check our website, you'll see what I mean. We've got a wide array of courses that can cover different competencies in different industries. We have the consulting arm as well, which delivers consulting and advisory services in HR, in strategy, quality, and finance. We are very proud to be client-centered. We work with our clients to deliver solutions, and we would like to consider ourselves one of the pioneers in delivering the training services and the corporate training services in the region. As I mentioned to you, we have over 26 categories in terms of the training that we offer. So all you have to do is check the category in front of you and then go to the website, and then you will find a list of courses that can cover many of the requirements that you might need for your competencies and upgrade of your skills. We have also a number of associations. Some of our courses are associated or accredited by a number of international organizations, including the American Society for Quality, including the Heriot-Watt University, the ILM, the Society for Human Resource Management, or SHRM. So we've got a number of programs that you will be required maybe to do an exam or a project to meet the requirements. This is me. I'm an engineer by training. Civil engineering is my bachelor's degree. Then I ventured into the quality field, and of course, I could not find better than a master's in industrial engineering, which basically become the consulting sort of skills needed for people to go into consulting. And then I, of course, did my PhD in business administration, but I focused on operational excellence, and I did it on a topic called Lean Six Sigma. So if you're familiar with improvement and continual improvement, you'll know what is Six Sigma, which basically uses the two tools that I will be talking about today. Moving from Canada to Dubai was a great step for me. I used to work with KPMG and with BSI and with IBM as a quality consultant, engineer, and auditor and training director with KPMG. I moved to Dubai, joined Merck Training and Consulting, and I became a partner in 2007. And ever since, I've been looking at the quality and operational excellence training and consulting. So that's me, focus on operational excellence, leadership training, and consulting. And this is where I'm very pleased to be here with you to try to pass the knowledge through my practical experience and consulting experience. Married, if you want to know that, and two children. Well, one is already in Montreal doing her Bachelor's of Science at McGill University, and my son is still here in Dubai. So that's me. Moving now to the topic itself, and why are we discussing this topic? The importance of the discussion, I sort of look at it as a physician who needs to understand the human body, and he or she needs to analyze the signals so they can provide the appropriate treatment option for the patient. For a quality professional, for someone who is working on continual improvement, basically the patient is the process. Hence, understanding the process itself, the signals, the variation, and its capability are key to continual improvement. So if you want to improve, you need to understand processes. And if you want to understand processes, you need the tools. Doctors, physicians, they use different tools, whether it's an X-ray, whether it's an ECG test, or whether it's an MRI. Well, in the quality field, we need tools such as these tools. And this is where we are discussing the control charts and the process capability charts as statistical tools to understand the process. Now, if you're familiar with the quality and improvement sort of domain, you must have run into what we call the 7 quality control tools. Now, these are, I would call them the fundamental, the basic. You cannot leave home without them. You have to be proficient in them if you want to venture into quality and improvement. So I'm sure if you look at this list, you'll see the control chart, you'll see the Pareto, you'll see the cause and effect diagram, a scatter diagram, check sheet, and we can spend, another 2 days talking about them. So what I did, I selected control charts and then the histogram, which would represent the process capability discussion that we need. So with that in mind, we're going to go now and talk about the control chart, which basically represents what we refer to as the statistical process control, or SPC for short. So it is the anatomy when you look at any process and you want to understand how that process operates. Now, a process, it could be the admission of patients in a hospital. It could be the check-in process in a hotel. It could be a transaction output in a service organization. It could be a manufacturing output for a part that they're measuring, maybe the diameter of that part. It could be a concentration of a solution in a lab. It doesn't matter. The process defined here as the transformation of inputs to outputs. Now, we're interested in measuring something about the process, which is a process output. So the SPC came in as a science developed by Dr. Walter Short in the early 1920s. Then Dr. Deming, of course, sometimes called the father of quality, he really focused on the application of it, and he went to Japan to teach the Japanese how to apply it, and then later on he came back to the US and transformed that knowledge into something they can use into their application. So when you look at a process chart or a statistical process control chart, there are elements that we need to have in place. We need data, and we need to look at this data from different perspectives. So if we want to ask what would be the applications and the aims of using a statistical process control. So let's see if we can run. I have a poll here, some questions maybe for you. So let me see if I can invite you to answer this question. So here we go. And you should see on the screen the question. Control chart. What is the primary use of control charts? Why would we use it? Is it to monitor process performance over time? Is it to detect special causes of variation? Is it to compare before and after improvement? Or is it all of the above? So let's see your answers, if I can get your answers. All right, all right. Good, good. All right, so I think we have some good answers here. Let's see the answers, and I'm gonna be sharing with you. All right, so here we go. And here are the results. Well, 20% of you said it's monitoring the process performance, and you're absolutely correct. I'm not going to argue with that. It is one of the primary uses, but we had 80% saying all of the above, and that is the correct answer, because basically a control chart is indeed monitoring the process performance over time, and it's telling you whether there is variation, and we call it the common variation versus the special causes or the special variation. So answer number 2, detecting special causes, is correct. And we use it as a tool, just like the doctors do. When they give you the treatment and you come back after the treatment, you are presented with a comparison, whether it's a lab test or an X-ray or an MRI. The doctor will show you these 2 results, and they will say, here we go. Here's before, here's after. You can see the improvement. And indeed, this is one of the main usages of control charts, because I want to use it to confirm my improvement. So whether you're doing a Six Sigma project and at the control stage, at the end, you want to see these comparison results, you can use it. Or if you just want to run an improvement project using the typical plan, do, check, act, you can or A3 as they call it in Toyota, you can use it as a tool to compare before and after. But we need data. We cannot have a control chart without data. So thank you very much. So the answer is all of the above. And let's move to the next thing. So the purpose, as you just confirmed to us here, it is about process variation. It is about looking at variation from what we call common causes, acceptable variation. In every process, there is some acceptable variation. And then there is a special variation, which we might refer to as assignable. There is something that has caused this special variation, whether it's a change of supplier, whether it is the power surge, something has happened that we can really assign. That's why it's called assignable. Or we can see some kind of a pattern or a trend, unusual, and it is showing in my graph. So I can circle and then I can go to the process owner and I can ask, why is this happening? Have you changed anything in the process? So it is for monitoring. It is for detecting whether your process is going out of control or already has gone out of control, as we will see now from the chart that we will look at. So it gives us that visual representation, and that's really very nice, because when we look at this chart, this is one of the types of charts, and you can see here, excuse me, you can see that any control chart has what we refer to as the upper control limit, the lower control limit, and the center line. Now, there are formulas to actually come up with these numbers. But in general, any control chart that you see captures what we call 99.73% of the area here. So between the upper and the lower. And then you can see the variation of the process. This is the output that we are interested in, and we are measuring that process variation. And immediately from that variation chart, you can see, maybe this point that is showing me something out of control. This is a special cause. We need to investigate, and we need to understand why did it happen. If we can understand, if we can put a corrective action in place, then we might be able to remove it from our calculation and regenerate the chart. But there are sometimes an acceptable percentage of special causes that might appear in any process, and we might accept it as part of the process itself. Now, if you start to see any trends, that might signal to you that there is some change, but having a variation sometimes between the center line going up and down is normal. I mean, that is common in life. When you sign your name for a bank, you would expect some variation. If you arrive to your office every day, there is some variation. So there's always this variation that we can accept, but as again, our objective is to try to minimize that variation and make sure that variation does not become excessive or create trends or go out of control. So when we start thinking about this chart itself, we can see here the same chart. You can see that it is common to have variation between the different center lines. And as we said, it represents 3 sigma up, 3 sigma down, which captures 99.73% of the process performance. So as if we are saying, if your process is ranging around the center line and capturing 99.73% of that area, then your process is exhibiting what we call stable. That's the word that we use, stability. And the whole idea here, when stability is presented to us in these graphs, we can somehow predict the future and how the process will behave. And that will take me later on to the discussion of process capability. So I can use it somehow to look at my current situation, but in the same time, I can get confidence that my process will continue to work in this manner as long as it is stable. So when we look at this process chart, we can see some points, as you can see here, that that we call special, assignable, and we might want to investigate why these processes or these points have gone out of control. We might need to go to the floor, to the people who are working, and asking them, why do we have that? So as I mentioned, these slides here just summarize what I just said. There is a center line, there is the 99.73% that is captured between the upper control limit and the lower control limit. And this control chart then becomes my map in deciding whether the process is stable or not. Now, when we take it to the next level, we will then talk about the process capability, which basically is something that we have to build on the control chart and create the histogram, as we call it, with the special or the specification limit that comes from the customer. But this is a very important step for me to try to understand how the process is behaving and whether it is exhibiting any type of excessive variation. Now, there are multiple types of control charts, just to complicate things for you. And whether you want to use the individual moving range, or whether you want to use the X or average range chart, or X average standard deviation chart, it depends here on the type of data that you are collecting from the process and what are you measuring. And then it depends on the sample size, and then it depends on the subgroup size. So these are part of what you need to understand in sampling and statistics. We will not venture into it right now because that will take some time. But what I'm trying to tell you that there are different types of charts depending on whether you are using continuous data or attribute data, or you are sampling in sample size is 1, or you're doing subgroup size sampling in 2 or 5 or 10 or more. So we have like some decision trees that can help us do this. I mean, this is an example of one of them, but Minitab, the software that we use a lot in analysis of data, especially in improvement projects, Six Sigma, has already built-in decision trees that can really help you to decide on the type of control chart that you are using. So here's one type, which is called the individual moving range. And it is basically capturing the process. Usually control charts come in pairs. So you've got the lower part, which is the moving range, and then the individual range in this chart, because it's called individual moving range. And we would start usually from the lower part, check. Yeah, nothing seems to be out of order here. I mean, this point might be a problem, but we might consider it okay. And then we go to the upper control chart and we can see a little bit of variation, which is fine as well, but nothing out of the ordinary here that might trigger our attention. Now, the nice thing that these softwares now are equipped with what we call tests. The test itself that is programmed into the software, so it will immediately show you in green, in red points, what are the points that might be in violation of the special causes or the test. I'll try to show it to you in Minitab as we get into the discussion. So here we go, another type, which is called the X bar R chart. This is trying to measure the range, which is basically the subgroup sampling. Once it happens, it tries to measure the range, and it provides sensitivity to the range differences. And as we said, the whole idea is to try to understand the special causes. So there are some rules that has been put for us, and if you consult any control chart statistical book or software, you will find that there are what we call the different types of rules to help me detect whether my points are assignable, whether there is something outside. I mean, obviously, if there is one point more or higher than the upper control limit or lower than the lower control limit, then this meets this requirement, right? This one here, right? So we can say, oh, this is not met. There are also, if you see 6 points in your chart in a row, decreasing or increasing, going up or down, that might trigger also a question mark why my process is not exhibiting that random variation. Something is happening, something is developing, and I might take the time to go and ask why my process is maybe shifting or trending in that way. So these are different types of tests. As I said, they are available on the tools. For example, Minitab. This is directly from Minitab, and there is a window that you can select the different types of variation test. So if you want this point, which is above the center line, 3 sigma up, 3 sigma down, so you can basically have that. So, you can select as many, you can be, very stringent. You can select all of them, or you can select a couple of them. Depends on how, how sort of you want to be strict with the rules. But again, you can select these tools on the software. And here we go. For example, this is the one point beyond zone A, right? So this is outside your control limits. And Minitab as a software will immediately highlight that in your data and tell you this is a red point. As we said, another area that is very important for us is to use the control chart to see whether any change we have introduced to the process has given me improvement. So if you are interested to reduce a certain parameter in a process, and it could be counting defects, it could be length, it could be a measurement, it could be anything in your process. I am now interested to reduce that. So what am I saying? I'm saying if I do a change in the process and then I collect data after the improvement, will my process show improvement? Well, we can show that on a control chart. And what we call it usually is the comparison between the before and after. And you can see here, this process had this picture here where it was varying. We had an issue here, fine. But you can see the center line here in green was, around maybe 4 or 5 like counts or defects. I'm interested in reducing it. So I made a change. At this point, I made a change in my process. And immediately after the change, you can see that the center line here dropped. And that means if my objective was to reduce something in my process, i.e. improve it, then I can show success using this chart. So this is a very important aspect of the control chart, is using it as a way to try to understand how we can improve. So I'm going to show you very quickly on Minitab how we can do this. And I'll open a file on Minitab and do the comparison before and after. So if you allow me, I'm going to just open the file right now and share it on Minitab on your screen. Now, Minitab is one of the very powerful software that can help us do lots of improvement. So here we go. And I'm sharing now the screen with you on Minitab. Now, Minitab, for people who are not familiar with Minitab, it looks like Excel, but it's not Excel. So you should find it right now. So here is some data. This data is about something that we are monitoring. It's called shrinkage. There is a date selection or a sample selection here. So every 8 hours, we are selecting 10 samples. And the data here shows me that I've been collecting data, but at one time, it's called benchmark, 200 sample sizes, sample size. I started to play with the variables. I reduced temperature. And then after I reduced temperature, I went ahead and changed another variable in the process based on my analysis. I changed the tool. There was a tool modification. So I wanted to see on a chart what is happening and how that change affected my process. Was it really something to the benefit of the process? Did I really reduce shrinkage? That was my objective. So what I can do here, I can go to something called stat, control charts, and then go to the variable charts, because data here is variable continuous, 4.792, 4.70. And then because it is selected in subgroup, the sampling is done every 8 hours. There are 10 samples. This is what we call subgroup sampling. And it is more than 8 as per the guidelines. I'm going to take something called what? I'm going to take, control chart, subgroup. I'm going to take something called X bar S. So here is my window, should appear. I'm now building my control chart. The subgroup size is 10, which means I'm taking 10 samples every 8 hours. Now I'm going to go here and do something called the stages. So the stages is asking the software Minitab to identify the improvement change by text. And this is where I'm going to take change. And I'm telling it, whenever you see on the C3 cell a change, consider it a new change that I have introduced to the process, and present to me a control chart with 3 sections: benchmark, temperature reduction, and tool modification. Let me see, did I really succeed in making this change? So if we do that, the chart is generated for us, and you can see here. Let me, if I can show you this bigger. Yeah, there we go. So if you look at this control chart, now split between 3 phases, to answer the question, did I succeed in, improving the shrinkage by introducing the changes to my process? Immediately you can see that. You can see that the changes or the shrinkage went down. It was around this. Now it's this. Now it's this. And you can see even the variation is less. So the variation between or around the center line, it's more hugging the center line, which basically now tells me my process is even more stable, less variation, and I have reduced my shrinkage by introducing the changes. So statistically, I have shown that I have succeeded in my efforts to improve this process, and this immediately presents to me a very nice chart I can present to my management, and I can say, look, I have managed to improve the process. And of course, you have to do some changes to the process to make this happen, right? I mean, the numbers here that you have selected are based on actual improvements on the floor, on the ground, and this is how we start to show our management that we are improving. So if we can go back to our slides, and we have just completed the control chart discussion. I know that we can discuss control charts in more depth, but again we have limited time for the webinar, so I just wanted to share with you some of the stuff that we do in our training courses. Another topic which is very important for us as quality professionals, people who improve processes, is understanding something called process capability. Now, process capability is what we want to know about my process capability, ability to meet customer demands, customer requirements, customer specification. And we are predicting this process capability. So it is based on the stability of a process. When I use the word stability previously, this is what I was referring to. The ability of the process to continuously give me what I want, which is the customer voice, and deliver it with minimal variation. This is process capability. So process capability is an index, a number that we can present to our management, to our suppliers, and we can use it as a way to understand what is happening in the process. Now, professionals have designed certain indices to tell me whether an index of 1 or 1.2 or 1.33 or 2, and they called it something called the CPK, process capability indices. Now, for people who are familiar with Six Sigma, well, Six Sigma metric came as a result of the process capability indices, the CPK, or defects per million opportunities. So when we say a process capability of CPK 2, which is equivalent to 6 sigma, which means that a process really has very good quality levels in achieving the customer requirements. So it's all about presenting variation. It's all about comparing how the process is behaving, which we refer to as VOP, or voice of the process, with the VOC, which is voice of the customer. So it's a comparison statistically presented to us between these two variables, so I can come up with that number that tells me whether my process is capable and will continue to be capable. And this is where predictability and statistics becomes very important, as long as all the parameters are in place and we don't change anything. So the process capability is, as I just said, if we want to define it, it's an index that tells me that a process is capable to provide what the customer wants. Now, maybe it's an SLA, service level agreement. Maybe you have you have a governmental objective to meet a certain time in your transaction, 3 business days. Yeah, we can do all of this, whether it's a transactional process, whether it is whether it's any type of transaction, any type of a process that generates that, we can actually do that, and we can present it as a process capability index. Now, we need to get data to understand that. We need to verify certain things before we get into process capability. For example, we need, first of all, to define the practical problem that we're trying to solve. We try to move it, of course, to a statistical model. So, i.e., I need to collect data about my process. I need to sample. I need to collect the voice of the customer. So I need to understand what is the customer tolerances, specification that needs to be available. And then I can put it together and I can present it and I can say, oh, my process seems to be off target. It's not actually, it is shifted. It's trying to achieve another target, or maybe it is skewed to the left or skewed to the right. So the histogram, one of the 7 quality tools, becomes my tool that I can use to present this visually, of course, by imposing what we call the voice of the customer. So if you look at this chart here, once I understand the process I'm trying to analyze, and I can collect the variables that I'm interested in and the why, we can take that why and then we can measure it. What do we mean by measure it? Sample, get data, go on the floor, get data, whether your system is generating that data about that why. That why, as we said, could be anything from time to measure to concentration. Once you have your why, you just plug it in and you generate your histogram. So whether your histogram is showing a normal distribution or a non-normal distribution, then there are ways, of course, to deal with that we discuss in our statistical courses and our improvement courses. Now, for the very simple example that we have here, we have a voice of the process, VOP, appearing here. And then we need to introduce to this chart what we call the VOC. So where do VOC come from? Well, these are the customer requirements, specification. They want them to happen. They want you to deliver something with this target. So, and they might accept the upper specification and lower specification. So anything that you deliver here and here is good for them. Anything which is outside the borders of the upper specification and the lower specification is considered a defect. Now, is your process capable? That's the question we wanted to answer. Well, it depends on visually on the shape of your process. Look here, you can see that we have a good number of maybe activities happening outside, which means your process is delivering something outside. Now, we need to translate this into an index. So if we can have maybe a process, let me put it in green, that looks like this. Maybe I have improved my process and it's a little bit, you can see that the tails are a little bit around the center, which means the probability to generate defects is less. Well, what I've just done here, I've improved the process, but I had to do something to improve it rather than just draw the green line. But what I did, I reduced the probability for a process to create defects. Now, a defect is anything which is outside of the requirements of a customer, whether it's time, it's concentration, it's anything. Now, if I do that, my process capability should go up. So the index that we were talking about, maybe it was 0.82, now it is 1.4. And that means that the probability of defects to be generated is less, i.e. process capability indices, as they go up, that means that the probability to generate defects, and then we have to define defect for that process, becomes less. So like if we look at this chart for this process, you can see here's my process. My process here seems to be very it's not flat. I'm not going to call it flat, but you can see the tails are going into the upper and lower and specification limits. You can see here. And that means that probability to generate defects is very high. The target is what the customer wants. The upper specification and lower specification are the tolerances. If you look at this process, you can see that the process itself is off target. Like this is my target. Here is what the customer wants, the target here, right? But your process has shifted to the right, i.e. something has happened, something which is we don't want to happen. My objective in any type of an improvement is to recenter the process and to reduce spread or variation, i.e. to get to this level or to this graphical representation of a process. If we do this, then the process capability would be higher. And this is where I can come in and then calculate some numbers for these capability studies. So the most famous capability studies they refer to as the CP or CPK. Now I'm gonna ignore CP because it has already some kind of a drawback that it doesn't consider the centering of processes, something, let's not discuss, but let's take something called CPK and say, okay, CPK is the one we are interested in. It is measuring the reality of my process performance, and it's telling me how well my process is behaving. So we can use a number of these indices, but most people will tend to use the CPK or PPK as well, but CPK tends to be the most common one. Now, to be able to calculate CPK, there are certain prerequisites. One of them is control chart, the one we discussed. It has to be stable, because if it's not stable, you cannot use the predictability indices in CPK. To be able to predict, a process has to be stable. And that's a statistical, rule, right? And once we establish stability, once we understand the distribution of the chart, we have to test whether it is normal or non-normal, because we can use various formulas for the distribution. And then we go ahead and we calculate the process variation. Now, the process variation and the process capability can be done using different formulas. I'm going to just jump here to the formula. And the formula here is, yes, for example, here, it's showing me if your CPK is more than 1, equal 1, between 0 and 1, what does that mean? You can see the process. I mean, definitely here, this is very bad. This is very bad. This is bad. We started to get okay, but we're not there yet. We have still a chance to create defects, things that will not be, customer will not be happy with. As we start to reduce the variation, your CPK becomes higher than 1. The magical number that industry will accept as good is 1.33. right? 1.33, that means that the number of defects that are generated are manageable. The number that we are looking at is around 6,000 out of a million time you run a process. So 6% basically. And that's an industry, if you ask me, that's an industry average. Now, for other industries like healthcare, aerospace, that might not be enough. You might need to go to higher than 1.33. Now, if you go to 2, which is considered very high, it is the equivalent of the Six Sigma level. The Six Sigma, which you say it is 3.4 defects out of a million time, which is considered a very high level of quality. So what is that formula I'm talking about? Let me take you to the formula itself. And here's the formula. So it's a minimum of a value, which is the upper specification limit, which is given to you by the customer, minus the average of the data, which is the voice of the process, divided by 3 standard deviation. Standard deviation can be calculated from the data that you have collected from the process, comma, and then the average X bar minus the lower specification limit divided by 3 times the standard deviation. So you've got 2 values. You've got this value and you've got this value. The data is given because you have collected data about the sample, the process you're investigating, and then you are basically having the data average from the data itself. So the X bar is here, the standard deviation, the data is given, and then you have 2 types of, or 2 data sets. You take the minimum, all right? And once you take the minimum, you have that CPK number that can tell you whether your process is capable or not, or whether it is suffering from any type of things. Let me show you here also. Yeah, for example, here's what is the CPK for this data. You can see this is my chart, right? The green one. What is my target? The target here, the customer wants is 155. Upper specification limit is this one, lower specification limit. And the standard deviation, because we have already the data, is 3.44, and the mean or the X bar is 150.26. So if you want to apply the previous formula, you just take the minimum of 165, which is the upper specification limit, minus the mean, which is the average, divided by 3 times the standard deviation, comma, there's my comma here, and then the second part of it. So you've got 2 values. And which one do we take? We take the minimum. So your CPK for this process, and obviously by visually inspecting it, you know the process is not doing well. Because if you look here, you've got lots of data, which is what? Like here, I want to put it in red, which is outside what? Outside your lower specification limit, which is basically creating, and it is not centered around the target, which is 155 requested by your customer. So you've got issues with stability, with issues with centering, I mean, and issues with variation. So your CPK is low, and that is not good enough. That means your process has a high capability of, or probability of, giving defects to the customer. We need to improve this process. And that takes us into the actual work that we do as quality professionals and improvement in improving processes. So any process we can basically transform into these graphs. You are the doctor. You are the one who is requested to analyze these charts and then say whether it meets the requirements or not, and then whether we can improve these discussions or not. So again, softwares have made our life easier. This is taken directly from Minitab for a data, and you can see here, it will give you all the required indices. You can see the CPK here. As I said, there are other indices, but CPK tends to be good enough. And you can see very low CPK in this case. And you can visually tell me why. Look at this process. Here's my process, the one that is here. You can see my upper specification limit is here. My lower is here. My target is here. What is your process doing? Your process is is shifted to the right. It's working something else. It's giving you output which is really away from the target, and lots of the points here are considered defects, rejects from the point of view of my customer. And you can see here that we have a very high defect rate. It's around 280,000 out of a million, which is like 28%. 28% of a defect. So obviously you need to improve this process by understanding and investigating why, and then making the changes, and then we can come back and we can maybe compare this chart with the improved chart that you have done. So very powerful tools that statistically can tell me what's happening. They can detect changes before and after, and they can, show me what's happening in my process. Control charts, variation over time, which to detect stability, and then process capability charts based on histogram to tell me whether my process is able to meet the customer requirements and whether I have really improved after a certain improvement projects. These are the two tools I wanted to share with you today. I know there's lots of things to discuss, and we can, spend more time, of course, on many of the details on generating them using Minitab. I quickly showed you Minitab as one of the softwares we use, but during our courses, we do give more training, of course, on Minitab and how to use it, and people become very familiar and very adept in using it as a tool, because it's a very powerful statistical tool that can be used for anyone who wants to improve, look at data in a different format. I do thank you. I took a little bit more time, but I do thank you for your time. And yes, I will take questions right now. I mean, again, these are our questions or our courses at Merck. You can check, and we have some questions. Yes, absolutely, please.
Hi, Dr. Fawaz. Thank you so much for your time. Really appreciate it. Very informative, in such an amount of small time, but very, very informative. Thank you for that. I have a very quick question regarding the industry best practices when it comes to the CPK calculations. You mentioned earlier about 1.3%, 1.3, which is about 6%, is actually considered to be good. Now, that would be for which industry? Because you mentioned earlier that there is pharmaceutical, there is aviation,
correct.
There is different types of industries with different types of CPK. So are there any international standards around the world which can help us understand better when it comes to CPK measurements? Let's say for example for food industry, specifically for food. So for food, what is considered to be a good standard for CPK? Is it above 1.3? Is it 2? Any idea? Or is there a place I can actually collect such standards? Thank you.
Thank you, Taimur. Thank you. As you said, it's challenge, doing it in such a short time. The 1.33 is actually an industry average established by many industries, including the automotive, manufacturing, that they have used 1.33, which is equivalent to 4 sigma, if you're familiar with the sigma also scale, which represents around the 6,000, which is 6% out of a million defects. So out of a million transaction you will do, you can get a maximum of, let's say, the 6,000. Which is the 6%. Now, in certain industries, as you mentioned, like the pharmaceutical, like the food industry, like the aerospace, certain sensitive industries, they might not be happy with the 1.33. So the customer might come in and say, look, your process capability should be higher than 1.7 or 1.8, or even they might take you to the level of 2 CPK, which is the 6 sigma equivalent, which is the 3.4 defects per million. So out of a million time you run something, the maximum probability that you will have defects is 3.4 times, which is considered very high. Now, what is the industry? I know the food industry, working with some food industry like El Marai, Kraft Canada, some of the industries will require you to be up there, because remember, you are now talking about the safety and of consumers. Now, you need to measure the output of the process to establish process capability. So remember, it's not across an industry, right? Because in your processes, you could have multiple processes, not only one process. So are you talking about packaging process in the food industry? Are you talking about the actual, the actual manufacturing process? Are you talking about, the sorting process? In certain processes, you can accept certain defects, but in other processes, your defect probability would probably need to go to above 1.7, 1.8. Is there a place you could look it up? The ones that I told you are done. I know in the US and Canada, we have some guidelines from the manufacturing, from the automotive. I haven't come into anything on an international level, honestly. So I have to say, I don't know. I have to research. Sometimes it's good to say, I don't know. I have to research. But the ones I told you about are taken from international standards, from the action groups, the automotive, aerospace as well. They use the 1.33 as a common number. I hope I have answered your question, Timur.
Thank you, Doctor. Thank you.
Any other questions, any other remarks? Feel free to send it by chat or verbal feedback. All right. Thank you very much. I hope you have enjoyed this session. I hope you have benefited from the session. Hopefully we will get to see you in person one day in the future. Thank you very much for your time.
Merck.com